So today 3.5 slope intercept form. Probably the form that most people like better than any of the others. Okay, standard form we had an x and a y in the problem. Every form of a line has an x and a y. But the m, that's what we call the slope, and the b is the y-intercept, where it crosses the y-axis. Okay, so let's first, before we get too far into that, let's talk about slope. There's a few different ways to think about slope. I think the best way is change in y over change in x. And I'll explain why in a minute. But another way to look at it is rise over run. And that's not wrong to think about it like that. And the other is we have a slope formula. y2 minus y1 x2 over x1. And we won't need to really use the slope formula for anything today. But here's why I like the change in y over change in x. The rise over run is great if you have a graph. But it's not great if you just have 2 points. Then you have to graph it, and then you could do that. So you kind of have to do an extra step. The formula is great if you have 2 points. But if it's a graph, it may not be as good. Change in y over change in x, it's good for both of them. And I'll show you how to use both, at the appropriate times. Okay? All right, so for the slope of a graph, we basically have 4 choices to describe slope. Okay, so we always look at lines from left to right. Okay, so this slope is from left to right is going up. So it's a positive slope. And this one is going down from left to right. So it has negative slope. If you had a line that is perfectly flat, okay, the slope is 0. It has no slope, but we'd say it's not like no solution or anything, just the slope is 0. Okay, and then if you had a line that was completely vertical, we say this has undefined slope. So another way you can think of slope is it describes how steep, like if you think about if you're driving on a road, is it flat? It has no slope. Are you going uphill? Then it has positive slope. Well, how steep is the hill? In that, the actual value for the slope describes it. If you're going downhill, it has negative slope. How much downhill? Is it steep downhill? Is it barely downhill? There's a way to describe that. You can't describe a line that's straight up and down. Well, how steep is that? Is it 100 feet? You go up 100 feet per 1 foot? Do you go up 200 feet per 1 foot? You can't describe it because it's completely vertical. Okay. All right. So some of your problems will be to just find I think it says describe the slope. That just means, is it positive, is it negative, like that kind of thing. And then to actually find the slope. So if we had this line, okay, and it said find the slope. Well, again, I like to think of slope as change in y over change in x. And the y direction is up and down. So again, left to right, I'm going to go up, and then I'm going to go over. So how many spaces did I go up? I went up 1, 2, 3, 4 spaces. So the change in y is 4. And then I'm going to go to the right. How many spaces? 1, 2, 3 to the right. So the change in x is 3. So the slope is 4 over 3. Okay. And a lot of times you will see fractions for the slope, and that's okay because we don't have to add them together or anything. So if we had this one here, this one here, so change in y, this time I have to go down. Again, remember, left to right. So start with the point that's farthest on the left. It doesn't matter if it's higher or lower. So what did I do to go down? I went down 1, 2, 3, 4, 5. And if I go down, that's a negative direction, so I would put -5. And then I go to the right 1, 2 spaces. So the slope is -5 over 2. You could put like the negative out in the front. Either one is fine. Okay. So change in y over change in x. All right. Excuse me. So then you'll have some that they create it in a chart. So we talked about last week, I think it was, like problems where there's a chart, and most of the time you just want to look for a pattern. So it doesn't matter which one you do first, but for the y numbers, I noticed that they all go up by 2. So for slope, y over x, so the y direction is a 2. And then the x direction, I noticed that it's going up by 3. If it was going down, you would put negative. Okay? All right. So now we're going to get into a little bit more of the line stuff. So first, you will have some problems that just ask you what's the slope and what's the y-intercept. So remember, the slope is the number that's by the x. Okay, so the slope is 2. The slope is not 2x, it's the number. Doesn't include the x. And the y-intercept is -1. And like, you're done. You don't have to do anything else. Okay, so some of the problems are just set up like that. Okay, so remember that a y equals a number line, just any number, is going to be sideways. So the slope is 0. And an x equal line is vertical, and that slope is undefined. So it doesn't necessarily have, the y equal line will have a y-intercept, like this one looks like it could be like -2. An x equal line does not have a y-intercept. Okay, so you'll have some equations that are like y equal mx plus b. You'll have one that could be y equals or x equals. Okay, and then you could have one that's like standard form. Okay, and so you can't just say slope, that's the slope, that's the y-intercept, because it's not in the right form. So I need to make it into standard or slope-intercept form by moving the x over. And now I can say the slope is -3 and the y-intercept is 4. Okay, so some of them will be set up for you. Some of them you will need to move stuff around by adding and subtracting. If there's a number next to the y, you'd have to divide, but you got to move stuff around. We talked about this in chapter 1. But if you're moving a number and a letter like this problem, the 3x, I'm always going to add or subtract it. If you're just moving the number and you want the letter to stay where it is, that's when you're going to divide, or sometimes multiply, but usually divide. All right, so now let's graph. So we looked at this is probably the easiest form to graph in, because you start with the y-intercept, and then do the slope from the y-intercept. Okay, so the slope is 2 and the y-intercept is -1. So -1 on the y-axis. Okay, and if the slope is a whole number like this one, you can make it 2 over 1.
Make it 6.
So if you have a change in y and change in x, so I go up 2 because that's y direction, over 1, that's x direction, and I have my 2 points.